Okay, bonjour tout le monde. So we are at the end of the second edition of our Mobility AI Forum. I hope everybody has find that there was interesting ideas that has been proposed and so on. I have to thank again all the organization that are related to the DEAL project and Mobility AI. IVADO, l'Institut Intelligence et Données, Amity, CRIAC, and IRT Saint-Exupéry that have helped us to organize this event. We will see us probably in Quebec City or in Montreal next year for the third edition. This is an invitation. I would like to say something about what I just see. What was my feeling about this second edition forum? I have to recall you that the basic problem is AI learns from example by or by interacting with an environment. So we have a very different framework to develop AI than what we are usually doing in usual programmation. And this is a basic problem of the problem is how can we certify such a system per se, more precisely in a mobile embedded system, so in an airplane or in a car, but in general, how can we certify AI if AI learns by itself, simply by learning from examples, right? And of course, we don't want to see a bad event like the Tesla accident that we have seen a few years ago. And how can we avoid this kind of problem? This is exactly what is the reason of the DEAL project and MobiliT.AI Forum is it gives us some kind of orientation of how we can do that in the future. So again, I recall that the DEAL project is something that related not only organization like CRIAC, IVADO, NET, and so on, but also many industrial partners and a lot of academic partners. So this is a very rich environment. We hope that we will be able to be at we will play a very important role on the problem of being able to certify AI. Of course, the DEAL project, I recall you that it's 27 partners, 60 expert engineering expert and so on. That comes from research, industry, and data science. So this very interesting point of view. And we are looking at some very particular strategy. We try to be able to certify machine, artificial intelligent machine by using what? By using many different expertise from all methods, machine learning, of course, software engineering, operational research, privacy by design. And we want to achieve this problem of certification by using different approach, explainability, privacy by design, theoretical guarantee. And what we add more focus in this forum, we look at what is the idea of robustness and what is the idea of what is out of distribution. These are basically the two, the robustness and out of distribution are the most important, I will say, most of the conference were talking about these idea during this present forum. So what I remember as so the main idea that we have discussed during these 3 days is what can be certification of an AI, right? And we start with this problem of what I will call the OOD challenge. We learn from some examples that are in some situation, and the AI will have to deal with other situation. We learn, for example, with simulation data, and the AI has to be deployed in real data. Or we learn where in situation where there is no snow, and the AI will have to deal with the fact that it's snowing or something like that, which recalls some kind of system. We want to learn a function. We have observation on a part of the function, and we want to infer what will happen, or if we are able to be good to make good prediction where we in situation where we are not we didn't have scenes data for that situation. So what can we do? Of course, we can gather more data, but is there other solution? And of course, what means out of distribution? What here it's clear that we are in distribution, we are inside this situation where we have in observation. Here we are out of distribution, but in practice, when we have a situation with very high dimension, what this kind of idea means. So there's a lot of presentation that talk about that. Patrick Perez, for example, say that this is the domain gap. Okay, so the fact that we have to deal with different weather, location, sensor specification, and so on. And so he say that we have to deal with the difference with what he call a source domain and a target domain. Futse also said this problem of having we have two different paradigm here. The fact that we are in a system 2.0, that means that we are trying to look at a situation where we deal with example instead of doing a situation where we have a usual control of what we are going to program in traditional programming. And Futse give some example of saying trying to make some tests that will cover all the possibilities that we can encounter. And if we can do that, of course, if we can do that, then we will have some kind of guarantee. Mario Marchand pointed out something interesting that related to that in his tutorial. He showed that there's a very old theory from Vapnik that has been forget, that was to define a guarantee, but with local specification. So you, instead of having a guarantee for the overall problem, that is the kind of guarantee that we have developed for the last 30 years, Vapnik says that you can also develop guarantees for local situation. And of course, if you are looking at the problem that is local, maybe the AI that will deal with this problem may be more simple. And so maybe it's more explainable, was possible to explain or give some kind of interpretability of the AI. And this very old theory that has been forgotten from Vapnik will give us possibly some kind of possibility of having guarantee with this idea of looking at different situations and of hoping that we will be able to cover all of them. Okay, so if you didn't have times to look at the tutorial, I think I suggest that you can go in that direction. Liam Paul says something exactly about the same thing, about this problem of transfer learning, or this problem of dealing with a situation that are not situation that the AI encounter in the training. And he defined two different types of uncertainty, right? He talked about aleatory uncertainty and epistemic uncertainty. And basically, aleatory uncertainty are the noise that you have in the data, and the noise that are basically due to the fact that the sensors are not perfect, or there are some kind of variable that you cannot that are related to the observation that you cannot observe, and so on. So you get this kind of data uncertainty. But you also have the model uncertainty, that how the model can deal with the problem, and how, if it's trained on some data, it can be able to do something correctly in slightly different data. And this is called the epistemic uncertainty. Um, and yes, the takeaway message of Liam was, we have to know how to calibrate that, right? And many other presentation about how we can achieve certification was about this idea. Are we able to have some kind of capability of at least detect if we are in an outlier situation where the AI should not try to accomplish this task? Or are we able to give some kind of guarantee of situation where we are not in the fully controlled data that we have in the learning phase? Futse gives some kind of definition that is very similar also, saying that basically the aleatoric uncertainty, what he called that the data issue, and the epistemic uncertainty was basically the related to the model and the implementation issue. And another point that is very important in this presentation was all the problem related to the perception. We are in mobility, so we have to deal with sensors. And so how can we interpret properly what the sensor are giving us? How can we have a good interpretation of the situation? For example, in an image, you see a pedestrian. So how can we explain to an AI what is a pedestrian? And of course, not run just try to not to hurt this pedestrian. And what is another car, and what is the meaning of the car, the red light in the backside of the car are on or off, and things like that, and so on. And of course, this gives you some planification option, and then you enter into the control situation. So that's what's basically what Pierre-Olivier gave us this morning in his talk. And also Juliette Mathioli gives some basically same idea. She called it the situation awareness. That is basically the first step that we have to, this should be, since we are dealing with sensors and automation, we have to deal with AI, but how AI can have some kind of situation awareness. Of course, when you have this situation awareness, then you can make some kind of planning and control. Also, Pierre-Olivier from LiDAR showed that there are various quality of sensors, and he presents us the LiDAR, which is probably one of the sensors that will be very important in the future for mobility, I think. Gives the interest and of LiDAR comparing with camera and radar. But of course, the problem of that is we have to not only to be accurate in order to give good situation awareness, but we have to be robust. We have to be able to not go into a truck like the Tesla did a few years ago. And of course, there will not be only one kind of sensors on board. There will be a lot of different sensors. And this is what Xavier Pierroton showed us, basically. And we need to know how to make a fusion of these data in order to have the best possible interpretation of the situation. And so there are many different possibility of taking different data and try to make them as one and only one. The AI will be able to deal with this multi-view, basically, type of data. And And so this is about the perception part of the presentation. Another very important part of the presentation was about trust. So basically, this is one slide of Guillaume Soudain that is from EASI, which is basically the, the organization that will have the last word about are we going to be able to put some AI on board of airplane or not, because they will say, yes, your certification process will be okay or not. And basically, the problem is about trust, right? And what trust mean? We have to be able to trust as the scientific people has to be confident that the AI can be trusted. So it will be possible to embed it in a critical system like an airplane. But we also have this problem of what is the trust of the population, and in that sense, this is more social acceptability of having an AI that will be replacing one and maybe two pilots in an airplane and things like that. So a lot of interesting reflection that Guillaume gave us. So the technical dimension of what means trusting an AI, the ethical dimension also has to be taken into account. Very interesting presentation. I think this is for people from academic like me, this is something that we have to keep in mind. At the end, it's not theorems and publication that is the objective. It's to be able to go see a guy like Guillaume and convince him that we have developed the proper system that can be trusted. And this is also what Juliette Mathioli gives some explanation this morning, though. So this trust problem, but also she pointed out a very interesting other situation that, for example, what she called the frugal AI problem, the fact that most of the time we don't have the possibility of having sufficiently enough data to make a proper learning using deep learning system, for example. And also that if we want to have this trust, we need to be able basically to have a better way of explaining AI. This is something that we have explored more in the first edition of the Forum MobiliT.AI. We didn't explore explainability much this time. We were more thinking about what means certification, what means out of distribution data, what means transfer learning, and so on. The explainability remains a very important issue. And because also of the frugal AI, Thales is looking at what she called hybrid AI, which means an AI that is both rule-based and more interpretable system, and also something that is like a deep neural network that is more a black box, even if it's more accurate than the usual symbolic approach. So how can we merge those two together in some way? In that direction, Mario Marchand in his tutorial gives some interesting way of using the strength of a neural network in order to use stochastic gradient descent in order to learn some kind of symbolic AI. So there are some kind of good direction in that I think that are interesting. But Guillaume also gave us something that is, I think, very interesting. So the EASA makes some reflection of what do we need if we want to be able to certify an AI in a mobility situation like what in an airplane. And so they have this first roadmap that you can get If you go to the ESA-Europea.EU site web, this is, I think, a very interesting reading that you should do. But don't forget what Frank Mamalet also present, the same kind of reflection that we did inside of the DEAL project. So how can we, the white paper about machine learning in certified systems. So this is also a very interesting reading about how can we develop theory in order to build system that on which we will be able to make some certification. Knowing that AI learned by itself, so it's more difficult to certify than usual software. I think this is the overall of what I see in this conference. Of course, I had to go somewhere else because I had this problem. There are some kind of little technical problem that we had at the beginning. I didn't see all the presentation yet. I will, because they are all recording. I encourage you to look at them, and also to look if what I've tried to tell you for the last 30 minutes is something that ring a bell. If you have the same perception of what I had of this forum. And before the next edition next year, that will be, I hope, in Quebec City, I invite you to, if you are interested, to join the regular meeting that we have in the DEAL project called Les Carrefour DEAL. So every first Thursday of each month, we have a morning. In Quebec, it's called a morning, and in Toulouse, it's called an afternoon, dedicated to some of the difficulty that we want to tackle inside the DEAL project. So each month it's different ideas. We have most of the time 2 presentations, one from the academic part, one from the industrial part, and then a little discussion out of that. So you are invited, if you are interested, to join the family and to try to help us to find solution of this very difficult problem, that is, how can we certify an AI sufficiently enough that we will be able to trust if it is inside a critical system like an airplane or a car or a truck or a train. Okay, I think I will stop here. If you have any question, Octavie, is there some question in the chat box or not?
No, sorry, no questions.
Okay, so I will thank you everybody. Again, see you in Carrefour DEAL, and see you next year for the 3rd edition of the forum. Thank you.
Thank you, François.
Bye-bye.
Bye-bye.